Alright, we're back. If this is the morning class, we're going to do both videos in the same day because you guys have the Musical Instrument Museum field trip tomorrow. If you're in the afternoon class, hopefully we've broken this up, and this is Thursday that you're watching this, alright? So, second part of the review. Let's look at that second section of the reading about speed and velocity, alright? Speed, average speed, instantaneous speed. Let's talk about that. Speed. This is your measurement of distance over time. How is your distance changing relative to your time? This is a rate, once again, okay? So how fast you're going, all right? And your average speed is your total distance covered divided by the total time it takes to make that trip, okay? So average speed, fairly easy to calculate, all right? We can do this, all right? We did it with the lab. Right? We took our, initial position, final position, initial time, final time. We calculated our average speed. You will need to be able to do this for the test. Okay. Instantaneous, let's go back. Instantaneous speed. Your speed at an individual moment in time. All right? You're not going to need to calculate instantaneous speed. I want you to know what it is because it's important for physics. I want you to have heard the term before. But you need calculus in order to determine your instantaneous speed. I'm not teaching calculus. You're not learning it this year. I want you to know there's a difference over average speed versus instantaneous speed. But you're only calculating average speed for the test. All right, graphing motion. We did a whole lab on motion, and you looked at graphs. Let's take a look at the four most common motions, all right? If my velocity is 0, if my velocity is 0, means I'm not moving. If that is true on my displacement versus time graph, my position is not going to change. It's going to be a flat line. My velocity is going to be 0. Why? Because my velocity is 0 by definition. And if my velocity continues to be 0, I have no change in acceleration, or no change in velocity, so my acceleration is 0 as well. This is the simplest case. When I'm not moving, my velocity is 0, which means my position is constant. Velocity is 0, acceleration is 0. Cool? All right. Now, if you are moving with constant velocity, forget this equation here, don't worry about it. It's a nice picture, so I like it. Oops. All right. If I have constant velocity, my position is going to increase over time. And if it does so in a straight line, it means my velocity is constant. What is my velocity? I don't know what it is, but it's definitely positive because I'm moving away from the origin. Okay. My frame of reference, here's my origin. I'm moving away from it, so I have a positive velocity. It's constant, it's horizontal, but it's not 0 like it was up here. All right. Now, still on my acceleration versus time graph, it's 0. There's nothing there. Why? Because my velocity is constant. It's not changing. And if my velocity doesn't change, I have 0 acceleration. Does that make sense? Okay. Constant velocity, position changes at a steady rate, constant slope. My velocity versus time, it's steady, it doesn't change. Because it doesn't change, my acceleration is 0. Because acceleration is my change in velocity. If it doesn't change, it's 0. Good? All right. Now, constant acceleration, constant deceleration. Let's look at acceleration first. When we accelerate, you're going to see your distance versus time, your displacement, I should say, my displacement versus time graph, curve upwards. Okay? That means a constant acceleration. I'm covering more distance in the same amount of time, which makes my line curve upwards. My velocity is going to increase. I'm going to see a positive slope for my velocity versus time graph. When my velocity versus time graph goes up, that means I have a acceleration, some sort of positive acceleration. Right? If if I decelerate, I'm going to cover less distance over time. You're going to see me curve downward. This is a concave down curve. You don't need to know that, but I want you to know the shape. Curves mean accelerations on my displacement versus time graph. You're going to see your velocity go down. When my velocity goes down, that means I have a negative acceleration. Here's 0. Here's my acceleration. It's below 0. It's negative. We say it's constant because that's what the situation is here. Constant deceleration means I'm slowing down. My velocity gets less over time. My distance versus time curves downwards. You're going to have to analyze graphs, just like we did in the lab. You've done this before. You've seen what graphs look like. You've seen the data associated with them. You've calculated it, but I want you to have that visual image. Okay? You will look at some graphs on the test. These are 4 good cases to know. Hint, hint, wink, wink, nudge, nudge. Okay? Good to know. All right. Reading assignment number 2. Talked about speed and velocity. Okay? We just did graphing motion right here. Let's talk about velocity. Velocity is my change in displacement divided by my change in time. Velocity is a vector quantity, so I need displacement, which is a vector quantity, to calculate it. Okay, you did this for the lab. Not super hard. Problems on the test are not going to be super hard, but you need to understand how to do a calculation for velocity. Right? Final displacement minus my initial displacement gives me my change in displacement. My final time minus my initial time gives me my change in time. Right? And we can combine velocity just as we combined displacements or any other vector. Okay? We use those arrow techniques. Okay? Then in a straight line we can add and subtract, positive and negative, just like we did in the last video. Cool? Velocity is a vector, just like anything else. Alright, moving on. We also read about acceleration. So what is acceleration? Acceleration is when your velocity changes. You either speed up or you slow down. Or you change direction. Acceleration can be a change of direction as well. Right? How do we calculate it? My change in velocity over my change in time. My acceleration measures how quickly my velocity is changing, how quickly I'm speeding up, how quickly I'm slowing down. That's how we calculate acceleration. V final minus V initial divided by time final minus time initial. Exactly what we did for the lab. Right? You're going to look at your rough draft for your calculations. You did this. We did it together in groups. You can do this. Right? Graphs accelerated motion. We just did that. Okay? So, oops. Let's see. There they are. Here are my graphs of acceleration. Right? Remember, distance versus time. Acceleration is going to give me a curved line. Curved up for positive acceleration. I don't like this. There we go. Curved. Where is it? Curved down for a deceleration. Positive acceleration, my velocity increases. Negative acceleration, my velocity decreases. Okay? In both cases, it's constant. This is constant above 0. There's 0. Above it, there's 0. Below it, negative acceleration. Cool? Alright. Did that. Did that. Instantaneous acceleration. Just like instantaneous velocity. You don't need to know how to calculate it for this test. I want you to know it exists because you'll see it in later science classes, but you're just calculating average acceleration, just like you're only calculating average velocity. You need calculus, you don't know calculus, don't worry about it, don't sweat it. You won't see instantaneous acceleration on the test. Cool. All right. Skills that you should know. We've talked about a lot of the information you should know. You need to know how to calculate displacement, those arrows. All right? There's examples in the book if you need. How to calculate velocity. We did this for the lab. There's examples in the book. You can look at. There's practice problems in the book. All right? How to calculate average acceleration. This is what we did for the lab. Final velocity minus initial velocity divided by final time minus initial time. We did this in the lab. There's practice problems in the book. Take a look. You need to know which units go with which concepts. Displacement is meters. I didn't put this on here. Time is seconds. Velocity is meters per second. Rate of change in displacement over time. Meters per second. Acceleration is a meter per second, or meter per second squared. Okay, we talked about interpreting graphs. Did that a couple times. You can rewind, go back to those pictures. And when we look at graphs, we're going to look at that slope. The slope, the slant of the line, how steep or shallow it is, tells you how fast things are changing. A steep slope means that things are changing fast. There's more change in less time. A more shallow slope means less change in less time. Perfectly horizontal means no change with time. Perfectly vertical can't happen. You won't see it. Okay. All right. Last but not least, lab topics to be familiar with. This may be reiterative. Is that the right word? Repetitive. That's what I was thinking of. But you know that there's 3 essay questions. They're all about the lab. So you want to go back and look at that rough draft. How did you analyze your motion from the graphs? How do you know when something is moving and which direction? Remember the first lab we did? Walking towards and away from the motion sensor. Which one had a positive number and had a negative number? You want to also analyze motion from data tables. How do you know something's moving? How do you calculate velocity? How to calculate acceleration? We went over those formulas, but you want to be familiar with how you did it in the lab. You can do this. It's not going to be super hard, but it's going to be similar to what you did in the lab. How do you analyze hypotheses with data? Okay? You need to be able to look at data with a critical eye and use a graph or use a table to draw a conclusion based on numbers. Not just your gut, not what you believe, but use the numbers to back up your argument and look at sources of error. There's always 3 different ways to improve an experiment. You can get more data, you can get better data, you can have a better experimental design. Think about those 3 things when you're talking about the lab. Format of the test, exactly the same. 10 matching, those are the vocab from the book. 15 multiple choice, about half from the videos, half from the book. There'll be 3 essays. You have to answer 2 of them. The third one is a bonus. Highly, highly, highly recommend you do the bonus. You can't lose points. It's well worth the time that you spend. Very generous with partial credit. Okay, give it a shot. What do you study? Study your notes from the videos. Study the notes from the reading. That's why I have you do them. Okay? That's why I have you keep a binder. I want you to have these things as study resources. Use the review sheet. Use this video. Use the rough drafts of your lab report, the calculations that you did, the Quizlet that I sent you. Okay? That's good for the vocab. If you have any other questions, email me. I'll be checking email. I'll email you back. Check your email before school. Hopefully we'll clarify any questions that you have. All right? Good luck. God bless. Study hard. Don't stress. Okay? You've done this. You've done this all before. If you've done your homework, if you've taken notes, you're going to be good. Okay? All right. The test is not super hard. There's a lot of stuff we learned. Go show off what you know. All right. We'll see you on Monday. Have a good weekend.